I'd like to now look at an example where you're solving, but the angle is not a single angle. Okay, in this particular problem, I first want to note that the angle that I have within my trig function is a half angle. Alright, now in this kind of a problem, they are going to have to tell you what interval they want you to solve over. In other words, they're saying solve this. They're going to have to tell you that they want you to solve it for 0 to 2 pi. Now the other thing that you have to realize is 0 to 2 pi, that interval is the interval for theta. Okay, now first thing I want you to do if you have a problem like this where it's not a single angle is I want you to make a note of where the angle that you're looking for or the angle that you're given is located. So in other words, on here, if my original value of theta is in between 0 and 2 pi, then the half angle is a half of that interval. Okay, a half of 0 is 0. A half of theta over 2 is theta over 2, which is the angle that you have within this particular equation. And then a half of 2 pi is just pi. And so theta over 2, the particular angle that is in this equation, is actually located between 0 and pi. Which quadrant is that? That is in either quadrant 1 or quadrant 2. So while solving this, if you have angles that fall in quadrants 3 and 4, we're not going to consider these angles because our half angle is not contained within that. Now there is some confusion because on this particular example, we're not wanting to solve for theta over 2. We're going to first solve for theta over 2, but eventually we want to solve for theta by itself. And so this is a little bit confusing. Think about it this way. If we were going to solve for theta between 0 and 2 pi, we usually would have two answers. Okay, in this case, we're only going to end up with one answer because of the half angle. Okay, let's solve this problem. Okay, I'm going to copy down the original. You have 2 cosine of theta over 2 plus the square root of 3 equals 0. Alright, we're going to subtract the square root of 3. So we're left with 2 cosine of theta over 2 equals negative square root of 3. I can divide out the constant that's in the front of the cosine. I absolutely cannot do anything at this point to get rid of the 2 that's contained below the theta. That is something I absolutely cannot do anything with at this particular point. So be careful. Alright, dividing out the 2, I'll end up with cosine of theta over 2 equals negative square root of 3 over 2. Alright, cosine is equal to the value x over r. In this case, we see that the x is negative. Okay, x is negative in which quadrants? X is negative in quadrants 2 and quadrants 3. Well, from what we said above, we need to mark out quadrant 3 because we're looking actually for this particular angle between 0 and pi. So we don't want to consider quadrant 3. So draw our picture. Okay. In this particular example, we'll have a triangle in quadrant 2. Okay, the sides are negative square root of 3. The r value is 2. That forces the other side to be 1. This is a special angle. We know the reference angle in here is 30 degrees. Okay. The value that we're wanting to find is actually, first of all, theta over 2. In other words, whatever angle that you're solving for is always the angle that's in the trig function to begin with, okay, at this particular point in the problem. So theta over 2 is equal to the angle from the positive x-axis around to the terminal side of the triangle we have drawn. Okay, you can see that in this case, theta over 2 is going to equal 180 degrees minus 30 degrees, okay, which is 50 I'm sorry, 150 degrees. Okay, now we're wanting our answers in radians, so what I'm going to do is I'm going to rewrite that, theta over 2, 150 degrees in radians. We can think about pi as being 6 pi over 6, and so this is 1 pi over 6 units away, so this is actually 5 pi over 6, what we have here. So pi over 2 is equal to 5 pi over 6. Now, from here, the final step on problems like this is to take this equation that you have gone and found and solve this equation for theta. So now, solve for theta. Okay. In other words, to do that, we have theta over 2 equals 5 pi over 6. To get rid of the 2 that's in the denominator, we'll multiply both sides by 2 over 1. So theta by itself is going to equal 2 times 5 pi is 10 pi over 6. And then that will reduce by dividing out a 2. Okay, so this would be 5 pi over 3, and that's my one final answer. This concludes this example on solving trig equations.